Okay, honors pre-calcers. We're gonna do section 2.5. You're gonna watch this quick video and then you'll have the rest of the time in class to work. So here we go. Um, we're gonna be talking a little bit more about imaginary and complex numbers and how they're involved as solutions in a polynomial. We've talked about this a little bit before, but the degree of a polynomial is the number of solutions it's going to have. So in this polynomial, our degree is 5. So that means we're going to have 5 solutions. Now, some of those might be imaginary. Some might be real. Imaginary zeros always come in pairs. And so our possible options, if we have 5 solutions, our possible options are that all 5 are real. All 5 are real. We could have, let's see, we could have 3 that are real and 2 imaginary. Or we could have 1 real and 4 imaginary. But we could never have 3 imaginary or 5 imaginary or 1 imaginary because they always have to come in pairs. This polynomial has a third degree, so that means it's going to have 3 solutions. All 3 of them could be real, or you could have 1 real and 2 imaginary, but we could not have all 3 imaginary because they have to come in pairs. Now, a conjugate pair means that, like, if 2 minus 3i is a 0, then 2 plus 3i is also a 0, a solution. And if 5i is a 0, then negative 5i would also be a 0. And you got to be careful of all this because oftentimes you'll be given only one of the imaginary and you have to know that there is a second because they come in pairs. So just always know that they should come in pairs. Even if you're given one, it's implied the other. Okay, so now on this problem we're going to find all the zeros. And we can do this a couple different ways. Let's try to factor this. It's a quartic, but whenever you have x to the fourth and then an x squared and then a constant, it's going to factor, it could factor like a quadratic would factor. But instead of just an x and an x, we have to have 2 things that multiply to an x to the fourth. So that means they're both going to have to be x squareds. And now I have to find something that multiplies to negative 4 and adds to negative 3. So that could be a negative 4 and a positive 1. And then this factor factors even farther. It's difference of squares. So it will factor into 2 things that look identical except one's a plus and one's a minus. Now this last one, x squared plus 1, that does not factor farther. It's not difference of squares because there's a plus here instead of a minus. Okay, so now that we have it factored, what are each of our solutions? Well, if you set x plus 2 equal to 0, then your solution is going to be negative 2. If you set x minus 2 equal to 0, your solution will be positive 2. And then what happens if you set this equal to 0? You're going to have to subtract a 1, and then you're going to have to take a square root, remember plus or minus, square root of a negative 1, so we're going to get plus or minus I. So there are 4 solutions, 1, 2, 3, 4, which makes sense because it was a 4th degree polynomial. Okay, now that was how we did number 1. We factored and we solved it. We wrote it as a product of rational factors. So we had all of these factors written out. Another way we could do it is to do synthetic division. and do synthetic division with the real zeros, which are -2 and +2. But let's say that you didn't factor it, or maybe that it couldn't factor. And so um, how would you go about doing that? Hang on a second, I gotta move this. Okay, so if you didn't go about the path of factoring, what you could do is you could graph the function. Okay, here's the function graphed out. And then I can look for the real solutions. I see a solution at -2 and I see a solution at +2. Those are the real solutions. And so you can do synthetic division with those two, break it down to a quadratic that you can factor and get the imaginaries. So here's what that would look like. Okay, back to the original polynomial. We had 1x to the fourth, we had 0x cubes, we have a -3x squared, 0 x's, and a -4. And we're going to do synthetic division, and you can start with 2 or -2, it does not matter. I'm going to start with -2. So bring the 1 down, multiply diagonally, add vertically, multiply diagonally, -2 times -2 is 4, add vertically, we get a 1, multiply diagonally, add vertically, multiply diagonally, add vertically. Okay, no remainder. That just verifies that -2 is the solution. And then now we need to do double-decker synthetic division with our other solution of +2. And it doesn't matter which one you would have done first. Bring down the 1, multiply, add, multiply, add, multiply, add. Okay, so now every time you do synthetic division, the degree drops down 1. It started off as an x to the fourth. The green stuff brought it down to an x cubed. The blue stuff brings it down to an x squared. So that's 1x squared, no x's, and a +1. Okay, so now if you take this and you solve, you would do x squared plus 1 equals 0. You'd have to subtract the 1, and then you'd have to take plus or minus square root of -1, which is going to be plus or minus I. So that would be the other way to do it. If you didn't want to bother with factoring, you could always graph it, find the real solutions, and do synthetic division with the real solutions, breaking it down to a quadratic that you can then solve and get your imaginary solutions. Okay. Now there's different stages of factoring. This is the same problem. When we first started factoring, we had it broken down to x squared minus 4 and an x squared plus 1. That's the least factored of all the factoring. Then what we did was we broke this down into x plus 2 and x minus 2. And then we had the x squared plus 1. This is called factoring over the reals because each real solution gets its own individual factor. So the real solution was -2 and the real solution here was +2. Each solution has its own individual factor. This factor over here is where our imaginaries come from, so it's not yet broken all the way down when it's factoring over the reals. If I factor completely, then every single solution would have its own factor. So -2 solution, that's its factor. +2 solution has this factor. And then didn't we have I and -I? So x minus I and x plus I would be our last remaining factors. It's factored completely because every single solution has its own factor. And again, the solutions or the zeros were -2, +2, I, and -I. So you can see completely factored, every single solution has its own factor. Factoring over the reals, the imaginaries get kind of sucked up into this statement right here, not broken down. Only the reals are broken down. And then over the rationals, it's the least factored of all of them. Okay, now if we have a problem like this, it's a huge polynomial. We're supposed to find the zeros and factor completely, but we're not given anything. So the only thing you can do is graph it first and look at the real solutions. Okay, so I see that it crosses at -2, and then something happens at 1. It's bouncing at 1. What does it mean when it bounces? That means it's a double solution. So it's going to count twice. So right now, my solutions are -2, 1, and 1. I have 3 out of my 5 solutions so far. 3 reals out of my 5 solutions, so that means that 2 of them have to be imaginary. I don't like the way I wrote that because that makes it look like 2 is a solution. So here's what I'm just trying to say. 3 of our solutions are real, so the other 2 are going to have to be imaginary for a total of 5. So here's what we're going to do. We're going to do synthetic division. We're going to break it down into a quadratic. So our coefficients are 1, there's no x to the fourths, 1x cubed, 2x squared, -12x, and an 8. And we're going to do synthetic division. It's going to be a triple decker because we've got 3 solutions. I'm going to start with the -2. Okay, multiply diagonally, add, multiply, add, multiply, add, multiply, add, multiply, no remainder, which you would expect because we do know that -2 is a solution. Okay, then do it with a 1, multiply, add, multiply, add, multiply, add, multiply, add. Okay, again, no remainder. It means we're doing good. All right, last time with the other one. Okay, so multiply, add, we get a 0. 1 times 0 is 0. Add, we get a 4. Multiply, we get a 4. Add, we get a 0. Okay, so it was a 5th degree. The blue brought it down to 4th degree. Green brought it down to 3rd degree. So red brings it down to 2nd degree. We're dealing with x squared plus 4. Okay, solve that and we'll get our imaginaries. So subtract the 4 and then take the square root, remember plus or minus, square root of -4, and we're going to get plus or minus 2i. There's your other solutions. So our 5 solutions are -2, 1, and 1. Those are our real solutions. And then we have a 2i and a -2i. Those are our imaginary. And then we've got our 5 solutions. Okay? All right. Really quickly, if it tells you to write a polynomial with real coefficients, 4 is a solution, so its factor would be x minus 4. 5i is a solution, so its factor would be x minus 5i. And remember, imaginaries always come in pairs. So -5i is also a solution, and its factor would be x plus 5i. And you're going to want